thank you very much, everyone. As a bit of a background, my name is Marta and I'm part of the university sustainability team. Our team's role in the university is to share best practice, support behavior change, and ultimately help the university become more sustainable and manage its environmental impact, reduce the impact, maximize the benefit for the communities, the economy, and we do that through everything that we do, including events such as this one. And as I'm sure you have heard, the 26th UN Climate Conference, known as COP26, has started yesterday. So this is the perfect time now to get a good understanding of what climate change is exactly, how it works, and what we can do about it. And this is exactly what we're going to do in today's session. We are joined by Dr. Rosie Anthony. Rosie is a lecturer in climate change and sustainability at our university, and she's also a researcher in areas such as renewable energy, carbon sequestration, climate change, and ecosystems. And she is here today to talk us through the basics of climate science so that we can all understand, again, how climate change works and what actions we can take to help our planet. Thank you very much, Rosie, for joining us, and over to you.
Thanks, Marta. You're very welcome. It's my pleasure to be here. So thank you very much for the lovely introduction. As Marta said, I'm a lecturer in climate change and sustainability here at the University of Salford. So today I've been asked to give you a whistle-stop tour really into what climate change is, to help give that understanding of what it is and what evidence we have for it and what impacts it will have, but also what potential solutions are there? What can you actually do to make a difference? So future climate change is one of the defining challenges of the 21st century, along with poverty alleviation, environmental degradation, and global security. Thinking has changed rapidly, particularly over the past year or so, and the problem of climate change is no longer seen as just a scientific concern. It encompasses economics, sociology, geopolitics, national and local politics, law and health, just to name a few. So thanks to the work of campaigners, the problem has become much more widely communicated, increasing awareness and more people wanting to make changes. I'm sure you will all remember seeing Greta Thunberg making her seminal speech to the world leaders, where she made history by telling them, "We'll be watching you." She went on to say, "How dare you? You have stolen my dreams. You have stolen my childhood," which encapsulates perfectly the urgency and scale of the emergency that we are now facing. Because we are now in a climate emergency. We've got less than 10 years to stabilise our planet's temperature at just 1.5 degrees higher than it currently is. And beyond that is devastation for our world's ecosystems. But what is climate change? And what evidence is there for it? Here we have a rather evocative picture of a polar bear. But is this all climate change is? How does it affect us and our planet? Perhaps most importantly of all, what is the solution? One thing is clear, we must act now. It was a climate emergency 2 years ago, but what has been done since? Every year counts, every minute counts, every action counts. So what is the greenhouse effect? Well, first, let's think about the sun. Life on Earth depends on energy coming from the sun. It is absorbed by the land and the ocean. This warms them up and radiates heat back towards space. But gases in our atmosphere, such as water vapour, carbon dioxide, methane, and nitrous oxide, block this heat from escaping by absorbing it, and this warms the atmosphere, much like in a greenhouse. And these are called greenhouse gases, and this is the greenhouse effect. This exchange determines the temperature that we have on Earth, and the greenhouse effect actually does occur naturally. It plays a really important role in making our planet hospitable for us. And without it, the Earth would be at least 35 degrees colder, making the average temperature in the tropics about 10 degrees C. So it's a really important thing for us. The main problem is that since the Industrial Revolution began in the 19th century, we've been burning fossil fuels, so oil, coal, natural gas. So these fossil fuels that were deposited hundreds of millions of years ago and releasing the carbon back into the atmosphere as carbon dioxide and methane, significantly increasing the greenhouse effect and elevating the temperature of the Earth. Now, we know this by studying the history of our climate. We can track how this climate has changed in the past using key archives found in marine and lake sediments, ice cores, cave deposits, and tree rings. So scientists have drilled over 2 miles down into the Greenland and Antarctic ice sheets and have found that over the last 500,000 years, when greenhouse gas levels go up, so do global temperatures. And you can see on that graph there, we've got the carbon dioxide levels in blue, and as they rise, the temperature levels in red also follow the same trend. Now, there is clear evidence that the levels of carbon dioxide have been rising since the beginning of the Industrial Revolution. Before we started burning fossil fuels, the concentration of carbon dioxide in our atmosphere was about 280 parts per million. But since then, humans have emitted a whopping 375 billion tonnes of carbon dioxide into the atmosphere. And as a result, atmospheric carbon dioxide skyrocketed to over 400 parts per million. That is until 2 years ago, when in May 2019, we actually reached an alarming milestone and we exceeded 415 parts per million for the first time in human history. To put this into context, since the Industrial Revolution, atmospheric levels of carbon dioxide increased from about 280 parts per million to over 400 parts per million, as we've just seen. But that ice core evidence shows that over the last million years, natural changes in the atmospheric carbon dioxide levels varied between only 180 and 300 parts per million. So really, it shows that the level of pollution we have already caused in 1 century is comparable to the natural variation that took thousands of years. So who produces the pollution? Well, according to the IPCC, the first major source of carbon dioxide is the burning of fossil fuels, since over 85% of global carbon dioxide emissions comes from energy production, industrial processes, and transport. As industry and wealth is distributed unequally, these emissions are not evenly distributed. So North America, Europe, and Asia emit over 90% of the global industrially produced carbon dioxide. Also, an important thing to note, historically, countries in the global north have emitted far more than countries in the global south. Now, the second major source, accounting for 10 to 15% of global carbon dioxide emissions, is as a result of land use changes. So these emissions come from primarily cutting down forests for the purposes of agriculture, urbanisation, perhaps roads. So when large areas of rainforests are cut down, the land often turns into less productive grassland with considerably reduced capacity for storing carbon dioxide. In this case, the pattern of carbon dioxide emissions is different, with South America, Asia, and Africa being responsible for over 90% of present-day land use change emissions. This raises important ethical questions, though, because it's really difficult to tell these countries to stop deforestation when historically this had already occurred in much of North America and Europe before the beginning of the 20th century. In terms of the amounts of carbon dioxide released, industrial processes still significantly outweigh land use changes. Now, of the almost 500 billion tonnes of carbon which have been put into the atmosphere since the Industrial Revolution, that only represents half of our total emissions. So it seems that around 50% of our emissions have actually been absorbed by the Earth, with 25% going into oceans and 25% going into the land biosphere. However, there is concern that this removal of our pollution is unlikely to continue in the future. As global temperatures rise, the ocean will warm up and be able to hold less carbon dioxide. And as we continue to deforest and convert land for farming and urbanisation, there will be less vegetation available to absorb carbon dioxide, again reducing the uptake of our carbon pollution, releasing more into the atmosphere. So we've seen what climate change is, rising greenhouse gas emissions that lead to increasing global temperatures. And since 1880, global average surface temperature has increased by just over 1 degree. Now, what evidence do we have that that is real? Well, the first bit of evidence is that greenhouse gases are rising in the atmosphere. So we've just seen that, and we have tracked their rise and we understand their role in past climate variations. We know from experiments, both in the laboratory and atmospheric measurements, that these gases do absorb heat when they are present in the atmosphere. We know that global carbon dioxide emissions increased almost 50% since 1990, and emissions continue to grow more and more quickly. The next piece of evidence that we have is that we know that there is a significant change in global temperature. Data from satellites and surface thermometer records show that the planet is over 1 degree warmer than before the Industrial Revolution. And if we keep emitting greenhouse gases at this rate, the world will actually be between 3 and 4 degrees warmer by the end of this century. What we can also see, if you look at the figure on the top right-hand side of your of the PowerPoint, is that there is this large, rapid warming in the northern hemisphere and weaker warming in the southern hemisphere. We've also seen sea level rise by more than 24% over the last century, and significant changes in the Earth climate system are occurring. This includes the retreat of sea ice, retreating mountain glaciers, and the shrinking of permafrost. Now, the main contributing factors to sea level rise are thermal expansion, changes in groundwater storage, glacier loss, and ice loss from Greenland and the Antarctic. Now, sea level change is connected to climate change in two ways. First, as grounded ice melts, the meltwater runs into the ocean, increasing the total amount of water in the ocean and therefore the sea level. We're about to see exactly what is happening and how much of that grounded ice we're losing all over the planet. But secondly, water expands when it is warm. And we've just seen that the ocean's temperatures are increasing, so the resulting expansion also raises sea level. What you can see from the figure is that sea level is not only rising, but the rate of that increase is also accelerating. Now, given the rapid warming that is occurring, particularly in the Arctic, we would expect to see reductions in the area covered by sea ice during the summer. So this figure confirms this by showing a clear downward trend in the area covered by the Arctic sea ice at the end of the summer. Measurements also show that as well as shrinking in area, sea ice has actually grown thinner too. So the sea ice around the Antarctic has remained relatively stable since the mid-1970s. And this overall pattern, the large losses of sea ice in the Arctic, but smaller loss in the Antarctic, matches those regional temperature trends that we saw on the slides a few moments ago, which shows that large, rapid warming in the northern hemisphere and weaker warming in the southern hemisphere. So the sea ice data confirm not just the overall warming trend, but also the global distribution of the warming. Now, we're also seeing a decrease in average glacier length relative to the length in 1950, and that is over the past few centuries. So the pattern of glacier retreat is consistent worldwide, confirming that the warming we're now experiencing is in fact global. So the Earth has two major ice sheets. one in the northern hemisphere on Greenland and the other in the southern hemisphere on Antarctica. And since the early 1990s, Greenland has lost roughly 3,000 billion tonnes of ice, with the rate accelerating over time. And we're also seeing comparable losses in Antarctica. So with all that data, we can see that the amount of ice on the planet is decreasing, which is consistent with measurements of rising temperatures from surface thermometers and the satellite data, and provides additional evidence that the Earth is in fact warming. Both the surface temperature of the ocean and its heat content have increased over the past several decades. Now, the heat content refers to the temperature of the bulk of the ocean, so not just that surface temperature, but the water temperature actually averaged over the entire depth of the ocean, which is around about 4 kilometres. We're also seeing an increase in ocean acidification, which has huge knock-on effects in terms of the various ecosystems. And we're continually tracking global weather and have seen significant shifts in the number and intensity of extreme events. Our weather patterns are definitely changing and are becoming increasingly unpredictable, more intense, and more frequent. We're seeing more and more uncertain precipitation events, massive storms and flooding events. Just think of the summer. We saw flooding events in Germany, England, China, Italy, Korea, Bangladesh, Venezuela, Mozambique. When I was delivering a lecture about the impacts of climate change a few weeks ago, at the very moments that I was delivering, there was a tropical storm that battered the Philippines. A few days later, there was severe flooding again in Kerala in India. We're seeing an increase in wildfires and the devastation that they bring. Think of Australia and California, droughts, and the list goes on. These events that were once described as 1 in 100-year events are now happening more frequently. We're seeing the effects much more locally, and this is a really important point because it's really important in driving home that climate change is actually real. And it could be responsible for a shift in people's attitudes and can actually help move towards a different behaviour. So driving that behavioural change towards fighting and taking action against climate change, because it's very easy to think, oh, that doesn't affect me. The impacts of climate change are seen elsewhere around the globe, but when they start to hit home, then it really does start to have an impact. We're seeing total devastation by these events. We're seeing irreparable damage to homes, to nature, to biodiversity. There's a loss of lives, a loss of property, and it can even force population migrations and bring along with that all of the pressures that entails migration. Seasons are shifting, and this has a huge knock-on effect in terms of agriculture and food security. We're seeing changes in flowering times for certain species, changes in birds nesting and migrating. Species are migrating, moving further north. And this can have a huge impact on biodiversity and ecosystems. Now, the data that we've seen is evidence that the Earth is unequivocally warming, and the impacts of the changing climate are seen at many different levels, whether it's local or national, at an individual level, communities, species, ecosystems, habitats, perhaps even continents. We're seeing potential impacts on freshwater resources and the ecosystems, coastal and ocean systems, and as already mentioned, food security and human health. Looking at the impacts of climate change is extremely important as it reveals the vulnerability caused and the need for adaptation to protect and build up resilience. Now, society can actually cope with some changes, but we are moving now to a point where the extreme events caused by climate change are actually surpassing the ability of society to cope with them. So this means that we need to build flexible and resilient societies that are able to adapt. And the good news is that in many areas, we can be flexible. But of course, the sad reality is that some coping ranges are just not flexible enough for the damage that has already been caused. And as a result, we will lose large numbers of species and ecosystems. We're seeing mass extinctions at a faster rate than ever before. So this is some information from a documentary that David Attenborough did last year. And what it showed us is that all groups in the natural world are in decline, and they have been since 1970. So vertebrate animals, such as mammals, birds, amphibians, reptiles, they've all declined by 60%. Large mammals have on average disappeared from 3/4 of the range where they have been historically found. And the really, really worrying thing is that this is happening simultaneously across the planet. In the Amazon, in Africa, the Arctic, it's not just one place. It's not just one group of organisms, but with all biodiversity everywhere on the planet. Now, extinction is a natural process. Populations grow, they live, they become huge, and then they decline. But the rate at which this is happening is now the problem. Previously, groups took over millions of years to go extinct, but here we're looking at tens of years. So extinction is now happening 100 times faster than the natural evolutionary rate, and it's accelerating. So the consequences of losing these species are incredibly sad, but also profound for us, the human race, as everything in the natural world is interlinked, and all parts of the system are required to make it function. Now, the documentary reminded us that we as humans often think that we're outside of that system, but actually we are part of it. We're totally reliant on it, in fact. And the problem that we're now seeing is that ecological systems are changing on a massive scale right across the globe, and this threatens food and water security. So we rely on insects for pollination of crops. We rely on below ground activity to break down soil organic matter. And that is really important for soil health and productivity. So a knock-on effect on crop growing. We're reliant on plants for food, for habitat, for the air that we breathe. We're also seeing an increased vulnerability to that sea level rise that was mentioned. So the IPCC reports that sea level could rise between 50 and 30 centimetres by the year 2100. Now, this prediction is of major concern to all coastal areas, as rising sea levels will reduce the effectiveness of coastal defences against storms and floods and increase the instability of cliffs and beaches. In the global north, many places, such as Britain and the USA, will actually be able to respond to this by adding just another few feet of height to sea walls around properties on the coast. We might be fortunate to be able to abandon some of the poorer quality agricultural land to the sea, where it's no longer worth the expense to protect it. We may be able to enhance the legal protection for coastal wetlands, which is nature's best defence against the sea. However, globally, there are some nations based on small islands and river deltas that face a much more urgent situation, where they do not have the ability or the finance to adapt. They may even face threat from being completely overwhelmed by the sea. So some small nations, small island nations, for example, may disappear completely under the sea level rises. Storms and floods are natural and major hazards that have the ability to destroy major cities and towns, homes, lives, and even economies, so can have a global effect. And we're seeing more and more frequent and intense storms, leading to an increase in flooding events. As global temperatures increase, heat waves will increase. As precipitation becomes more variable and concentrated into more intense rainfall events, droughts will also increase. And these can lead to the deaths of many vulnerable populations, and also have severe impacts on agriculture and, again, ultimately, global food security. Now, there are lots of potential health impacts with the changing climate. Climate change will increase deaths from heat waves, droughts, storms, and floods. We've seen the impacts of extreme weather events across the world in the past couple of years. It will also increase vector-borne diseases such as malaria, as there's a shift in places that these are found. As the temperatures are changing, there will be more areas suitable for malaria transmission. We might see an increase in air pollution, which has an impact on respiratory and cardiovascular illness. Also, cancer risk can increase. Water pollution can lead to gastro problems. Plastic pollution is a massive problem within ecosystems, and no one is quite sure yet of the effect on humans through the food chain. There's also something else really important to consider in terms of health and climate change, and that is the impact on mental health. So there may be the impacts of eco-anxiety, so anxiety and depression. There could be the very real impacts of severe mental health distress after one of these extreme events. So people may suffer from post-traumatic stress. There may even be stress associated with forced migration. How do I afford to move after having lost my home? How do I feed my family? Those sorts of huge impacts on families and individuals, leading to severe mental distress. As I've mentioned, there are severe impacts on water and food that is available for us. And the most important threats to human health are actually associated with these. The lack of access to fresh drinking water leads to dehydration, but also increased risk from diseases and parasites in dirty water. Migration may lead to an increased pressure on an area's water resource, may lead to conflict. We also need to take into account, with rising populations, increased extreme weather events. Water security is an extremely important global issue. Now, changes in the climate, such as those associated with temperature, precipitation, length of growing season, and extreme weather events, will all impact the production of food. There may be a loss of cultivated land, a loss of farm area, a decrease in yield through the changing temperatures and the effects that has on certain crops. And this can affect quantity and quality of the food produced. And that will have an impact on what is available for global consumption. The current loss of biodiversity around the world is due to human activity, including deforestation, agriculture, urbanisation, and mineral exploitation. Now, biodiversity is vanishing at an astonishing rate, and 1 million species, both animal and plant, are now at risk of extinction. And as the documentary I mentioned earlier highlights, this is a critical moment. We're now facing a crisis that threatens us all, and we could lose critical parts of the Earth's system, which would threaten our food, our water, our climate. Some species most at risk are on the slide for you to see. So the mountain gorilla in Africa, amphibians that live in the cloud forests of the neotropics, the spectacled bear of the Andes, forest birds of Tanzania, the Bengal tiger, the resplendent quetzal bird in Central America, wetland habitats and their associated species, for example, those in the Sundarban wetlands, rainfall sensitive plants only found in the Cape Floral Kingdom of South Africa, polar bears, penguins near the pole. And the primary reason for the threat to these species is that they are unable to migrate in response to climate change because of their particular geographical location or the encroachment of human activity, particularly farming and urbanisation. So more and more, we are all being impacted by climate change. Though we know that those who are most impacted by climate change are the most vulnerable populations in society and those who actually contribute the least greenhouse gases. So climate change is a human rights issue as well as an environmental one, and it affects people disproportionately around the globe. So what is the solution? Well, 2020 was the warmest year on record and the end of the warmest decade that was ever recorded. 2019 was the year that carbon dioxide levels and other greenhouse gases in the atmosphere rose to new records. So it is imperative that urgent action needs to be taken to combat climate change and its impacts. Climate change is affecting every country on every continent. It is disrupting national economies and affecting lives. Weather patterns are changing, sea levels are rising, and weather events are becoming more extreme. Now, greenhouse gas emissions did actually drop about 7% in 2020 due to travel bans and economic slowdowns resulting from the COVID-19 pandemic. But this improvement is only temporary. Climate change is not on pause. The global economy has begun to recover from the pandemic, and emissions levels are rising, and they're expected to rise to higher levels than they were pre-pandemic. Saving lives and livelihoods requires urgent action to address both the pandemic and the climate emergency. So the most logical approach is to significantly cut greenhouse gas emissions. But how much do we need to cut them by, and how do we go about doing that? So in response, the UN organised the Conference of Parties, something I'm sure you've all heard a lot of recently. And it's essentially an annual meeting of the nations of the world in order to move negotiations forwards. So in December 1997, the first international agreement, the Kyoto Protocol, was drawn up. And this stated the general principles for a worldwide treaty on cutting greenhouse gas emissions, and more specifically, that all developed nations would aim to cut their emissions by 5.2% on their 1990 baseline levels for the first commitment period. So it committed industrialized countries and economies in transition to limit and reduce greenhouse gas emissions in accordance with agreed individual targets. So the convention itself only asks those countries to adopt policies and measures on mitigation and to report periodically. It established flexible market mechanisms and allowed the trade of emissions permits. So we have the international emissions trading, so essentially carbon trading come out of it, which allowed countries to sell excess capacity to countries who were over their targets. It enabled the clean development mechanism, where emission reduction or removal enhancement projects were supported in developing countries, and the joint implementation scheme, in which developed countries were able to reduce emissions in other developed countries. So essentially, the take home message from the Kyoto Protocol was that it allowed the most cost effective reductions in emissions to take place, under the principle that it didn't really matter where the emissions are reduced as long as they're removed from the atmosphere. But was it a success or a failure? Now, there was a 5% reduction in emissions, but was that mainly due to the collapse of the Soviet Union around that time? 5% is a very small step. Much larger reductions are needed. However, I think the Kyoto Protocol was actually really useful because it was really successful at putting a framework in place and starting that motion. Now, after Kyoto, there was a lot of inaction and a lack of real commitment. Deals were struck where there was an intent to reduce emissions, but with no real agreement or framework in place for actual commitment. And that is until 2015, the Paris Agreement. So, the central aim of the Paris Agreement was to strengthen the global response to the threat of climate change by keeping global temperature rise this century well below 2 degrees C above pre industrial levels. So, excuse me, in essence, to pursue efforts to limit the temperature rise to 1.5 degrees. Additionally, the agreement aims to strengthen the ability of countries to deal with the impacts of climate change. So the agreement also provided enhanced transparency of action and support through a more robust transparency framework where all parties must regularly report on their emissions and on their implementation efforts. So it really looked at mitigation, so prevention of the problem, which is basically addressing the cause of climate change by reducing greenhouse gas emissions, but also looked at adaptation mechanisms, so helping to build resilient communities to cope with the impacts that we're already seeing. So I won't go through this slide too much, but the Paris Agreement talked about this limitation at 2 degrees, which is the actual tipping point when actually almost all people on the planet will become losers from climate change, versus this idea of limiting it to lower than that, and so limiting it to 1.5 degrees, which is logical, but actually is that far enough? So if you have a look at the slide in more detail later on, you will see the impacts of a 1.5 degree rise versus 2.5 degree rise. Now, despite the Paris Agreement, global carbon emissions have continued to rise every year. The only exception, as I mentioned, was last year when the global lockdown prompted a 7% reduction, in greenhouse gas emissions. And that was basically because the world came to a standstill. By stopping almost all flights and car journeys around the world, we had a small impact on our total greenhouse gas pollution. It was, however, temporary and it came at a huge cost. But I find the analysis really useful as we consider deep structural change needed to shift the global economy to zero emissions. Things like how a fall in road traffic, which is a main driver of global emissions, can actually have an impact. So if we encourage cycling and working from home, things like that, after the pandemic, our climate goals will become far more achievable. And I also think it gives us a glimmer of hope that we had a world emergency with the pandemic and we responded globally to an emergency and we were able to slow that spread and transmission of disease down. That gives me hope that if we respond to the climate emergency as a real emergency, then we can actually do this. We can stop the impacts of climate change before it's too late. What we do know is that a post-pandemic recovery must be a low carbon one. So the figure on the right-hand side of the slide was produced this year by the IPCC, and it shows with high confidence that there is a near linear relationship between the carbon dioxide that we emit and the temperature increase. So essentially, to reach net zero anthropogenic carbon dioxide emissions is a requirement if we want to stabilize that human induced global temperature increase. This is the Climate Action Tracker and it was updated last month, and it's an international organisation that have actually assessed the progress of 32 countries that signed the Paris Agreement and implemented their climate pledges. So the dark colours are incredibly insufficient action through to more sufficient levels. Almost all countries are failing to meet the Paris goals with the current commitments. If we continue with the current commitments, the temperature of our planet will increase by at least 3.2 degrees by the year 2100. And remember that the emissions are still rising. So we've seen that climate change is a very real and immediate threat, one that is having severe impacts on the planet and its people today. These impacts are only set to worsen. Climate change threats need to be addressed and mitigated in order to meet development needs. in order to be able to meet the needs of the present and those of future generations. So, who has responsibility? Is it governments and world leaders who play a role in creating and enforcing legislation and providing funds for emissions reductions? Fossil fuel firms, large corporations, small businesses, organisations, communities, individuals? Well, the answer is, of course, all of them. Everyone needs to take responsibility, and the key way to solve the climate problem is action by everyone. Every single one of us need to take responsibility to understand the facets of climate change, which extend beyond just the science of the environment. Now, the UK and Italy were supposed to hold COP26 last year, but due to the pandemic, it's actually occurring now, this very week in Glasgow. And this meeting is critical because it will review the progress made since the Paris Agreement in 2015 and encourage greater commitments and pledges from countries to cut their greenhouse gas emissions. Importantly, this will be the first COP meeting where a net zero carbon emission target will be the primary global ambition. And the discussion will be about how fast this can be achieved and which countries will lead. It will also be the first meeting with the USA having signed back up to the Paris Agreement since President Biden took over. So what can we do? We know that time is running out. We've got less than 10 years left to stabilise our planet's temperature at just 1.5 degrees higher than it currently is. What can we do to protect our oceans, our ecosystems, our biodiversity, our future, the future of our children and their children? Well, sometimes it's really difficult to understand the terms, so just do a little bit of explanation of them. We hear a lot about decarbonising the economy and moving towards net zero, but what does that actually mean? So, net zero carbon emissions means an overall balance of carbon dioxide going into the atmosphere and being taken out of the atmosphere. So, let's imagine a bath full to the brim of water. Now, the bathtub is our atmosphere, the water is carbon dioxide. Because we don't want the bath to overflow, we pull the plug and some water will trickle out. So the water flowing out is the offsets, things like tree planting, carbon capture, etc. But we still need some fossil fuels for society to function. And this is represented by turning the tap on. Now, net zero would be the tap running at the same rate the bath drains. So the amount of water in the bath doesn't actually change. But at the moment, the bath is overflowing. We're emitting far more carbon dioxide than is being taken out. Some countries, cities, and businesses have net zero commitments in place to lower emissions, but some of these goals are looking towards 20 plus years in the future, by which time it will be too late. The problem with offsets? Well, it encourages us to keep polluting. And carbon dioxide lasts in the air for decades, and we don't have decades to keep accumulating emissions in the atmosphere. We also hear about reducing our carbon footprint. So the carbon footprint is basically the amount of greenhouse gas emissions released into the atmosphere as a result of the activities of a particular individual, an organisation, a product, a supply chain, or even a community. So we can look at our lifestyles and determine where carbon savings can be made. So, for example, taking less or even no flights, reducing the use of your car, perhaps changing to an electric vehicle, or getting rid of it altogether, using active transport where possible. And that's just a form of getting somewhere where we are active, so cycling or walking. By using a more efficient petrol or diesel car, you could save 0.9 tonnes of carbon dioxide a year. A fully electric vehicle could save you 2 tonnes a year. Reducing the amount of red meat you eat could reduce emissions by 0.8 tonnes of carbon dioxide. You could choose to eat more locally and seasonably available foods. Just looking at your lifestyle and determining where you could make some savings. Another important aspect, which we hear quite a lot of in the news, is to actually think about the efficiency of the energy within the home. Now, according to the Committee on Climate Change, 40% of UK emissions come from households. This means our homes have an important part to play in meeting emissions reductions. So this includes things like heating, electricity, transport and waste. We can save energy within the home through a number of different ways, such as better insulation, smarter lighting and appliances, smart heating systems. And the added benefit of being more efficient with energy is that it not only reduces greenhouse gas emissions, but it will also save you money. By reducing and sorting waste, you can reduce your household emissions by about 0.25 tonnes of carbon dioxide a year. Think about how all of these changes add up in terms of just your household. And then think about it if everybody on your street did it, in the village, in the town. Think about if everybody took responsibility and cut their individual emissions. So we're nearly at the end now, and I've got a summary of action. So first of all, I think it's really important to urge governments to take bold, ambitious climate action now. We know that COP26 is taking place, but we need to have climate plans and accountability legislation that is actually strong enough to meet goals. It's really important that we don't surpass 1.5 degrees warming. So if you're in a position to, sign petitions, write to your local MP, actively voice your opinion. Use your energy wisely and save money while you're doing it. Switch to renewables. Eat for a climate stable planet. Eat more meat free, but also buy locally, seasonally. Try to reduce your food waste. Maybe even grow your own. One of the really important things and that I'm passionate about is to start a climate conversation. Solving climate change requires us all to work together. We can't do that without finding common ground with those who may not share our perspective. Raise awareness, help educate others, and help them to make changes. You can green your commute, consume less, waste less. Society's changed an awful lot over recent decades with this focus on overconsumption. We now have a throwaway culture, and this is damaging in terms of the Earth's resources that are being used up and the emissions that are emitted into the atmosphere to produce those goods, not to mention emissions associated with the end of life of that product. Sharing, making, fixing, upcycling, repurposing, composting are all good places to start, and we need to start shifting our mindset away from that of consumerism. Mobilise for local climate action and get politically active and vote. Enacting what may seem as small changes will add up. It will be an example to others, and when they're seen as a whole, so the results of lots of people taking small actions, they can act as a powerful influencing tool and can enable the systemic change that is needed to mitigate the impacts of climate change. If we are to solve the problems of climate change, we need to tackle two fundamental problems. The first is how we can reduce the amount of greenhouse gas pollution that we're emitting, and the second is to ask a question. Are we as a society prepared to invest for the sake of our future? To make even small amounts of carbon storage in some reservoirs, to reduce our emissions, to live more sustainable and climate friendly lives. It is imperative to have societal and political support. It's also important, really important, to raise awareness, encourage action of all kinds, and put pressure on those in power making policies and those responsible for enforcing them. We must act now. We can make changes in our own lives, educate others, and put pressure on those around us making decisions. I think it's possible for us as a society to do, but it is extremely challenging from a political point of view. As always, it comes down to educating people, having the fundership and the leadership to make changes, putting into place those robust policies, legislations, and regulating them. Whilst we know the importance of systemic change, in fact, we need to use every single solution that we have to tackle climate change. It's incredibly important to have strong and decent leadership who at least use the right language and have good intentions, thinking about the balance between environmental issues and the economy, or shifting the thinking and looking to the longer term economic benefits of tackling climate change now. But the biggest question for me is, how do we enact this change? Where do we draw the line between meaningful and useful activism that can push for change and civil disobedience that takes things too far and potentially disengages people? In a world where there are terrifying threats, temperature rises, weather extremes, biodiversity collapse, mass extinctions, loss of livelihoods, homes, lives, impacts on food production, health, security, and where we have governments that are saying they are pushing for change whilst actually still funding giant fossil fuel companies or signing off on new oil fields, where we have high ambitions but the lack of policy behind them. Change is not passive. We need to come together and collectively take action, force our governments and the large companies to take responsibility. Thank you.